Hello again, Algebra 1. Today we are working on section 7 in chapter 6, where we're going to be multiplying a polynomial by a monomial. Let's just talk real quick about that vocabulary. Remember, a monomial means it's a single term. It can be a number, it can be a variable, or it can be a product of those. Polynomial, you could have a monomial, which is one term. You could have a binomial, which is 2. You could have a trinomial, which is 3, or you could have more than that, and at that point we just call them polynomials. So this is where your learning of the rules of exponents from the beginning of the chapter is so important, because we need those rules as we are going to be doing some multiplication today. So let me just remind you of one rule in particular, the power of a product. When you're multiplying two things and their base is the same, remember that we keep the base, but we add their exponents. That's probably going to be one of the biggest rules that we're going to need to be able to use in this section. So just keep that in mind, and if you've forgotten about that, pull those notes back up and take a look. So example number 1 is all about just doing the distributive property. And normally we're used to distributing just a number, but we are distributing a number and a variable. So we're going to be taking that 5a and we're going to be multiplying it times each of those terms. Now as we get started, I'm going to kind of show my work here in this first step, and probably at some point you're not going to want to show all this work, and I totally get that, but I'm going to show it just so you have this visual. So I'm taking the 5a and I'm going to multiply it times the 3a squared. Then I'm going to keep that plus sign. And now I'm going to take the 5a and I'm going to multiply it times the 4. So here's where the first half of the chapter comes in handy. So I'm going to multiply these two together. Well, 5 times 3 is 15. And then I notice that these have the same base of a. So I'm going to keep the a, but this is where I want to add the exponents. I don't see an exponent here, but it's understood to be a 1. And 1 plus 2 is 3. So that turns into 15a cubed plus... Now I want to multiply 5a times 4, and that's going to turn into 20a. And then I'm going to ask myself, can I combine like terms? So we just talked about that this week. When you're combining like terms, that means two things have to be true. You have to have the same variable, and the variables have to have the same exponent. Well, we do have the same variable of a, but they do not have the same exponent, and so that means that this is where I'm going to stop. There's nothing that I can do any farther than that. So let's jump into example 2. Again, I'm just going to be doing the distributive property, and I'm going to show my step here. So I have 2m squared, and I'm going to multiply that times 5m squared. Then I'm bringing down that minus sign, and I'm going to take that 2m squared and multiply it times the 7m. And then I'm going to bring down that plus sign. And then lastly, I've got the 2m squared, and I'm going to multiply it times the 8. All right, so 2m squared times 5m squared. Well, 2 times 5 is 10. Here I have the same base of m, so I keep the base, add the exponents, so 2 plus 2 is 4. So 10m to the 4th power minus 2 times 7 is 14. Same base of m, so you keep it, but you add your exponents, so 2 plus 1 is 3. So minus 14m cubed plus, last one, 2m squared times 8 is 16m squared. Notice they all have the same variable, but they don't have the same exponents, and so that means that we cannot simplify that any farther. Okay, same thing for the next one. So I'm going to do 1/2 k times negative 4k squared minus 1/2 k times 3. All right, 1/2 times negative 4 is negative 2. And then I have the same base of k, so keep it, add the exponents. So I'm going to get negative 2k cubed minus 1/2 times 3 is 3/2. And then keep the k. They do not have the same exponent, and so we are done. All right. Same thing. So I have negative 5g squared, and I'm going to multiply that times 3g squared plus negative 5g squared. I keep breaking lead left and right. Negative 5g squared times 4g minus negative 5g squared times 1. All right, so negative 5g squared times 3g squared. Well, my coefficient is going to be negative 15, and then I'm going to have g to the 4th power. For the next term, negative 5 times 4 is going to give me a negative 20, and g squared times g is going to be g cubed. Again, keep the base, add the exponents. Lastly, back here, I get these two minus signs together. We remember that that means that that's going to turn into a plus. So I'm going to have plus 5g squared. And again, this is as far as we can take it because although we have the same variable, they do not have the same exponents. So you're probably thinking it's pretty easy so far. When's it going to get hard? Well, not yet. Shane, that was for you. Don't worry, I can't actually hear you complaining. I like to believe that you're not complaining, that you have a great positive attitude, that all of us have a positive attitude while we're stuck at home doing math problems for fun. Maybe not for fun on your end, fun for me. All right, here we go, let's distribute. So we have 2/3 ab squared times 9a cubed b squared minus 2/3 ab squared times 15ab squared minus, can y'all hear my chair squeaking? I'm sorry. 2/3 ab squared times 24a squared b. Honestly, with these problems, that's the hardest part, and it's not hard, it's just tedious writing everything out. So let's do some math. So I have 2/3 times 9. I'm going to put that 9 over 1. I'm going to do a little bit of cross canceling because 3 goes into 9 3 times. So now I'm left with 2 times 3, which gives me a coefficient of 6. Then I have these a's. So I keep the base, but I add the exponents. This has an exponent of 1. This has an exponent of 3. So my new exponent is 4. Then I notice that I have the same base of b. So I'm going to keep the b, add the exponents. 2 plus 2 is 4. So my new term in the front is 6a to the 4th power b to the 4th power minus. Now let's go to what's going on here in the middle. I'm going to put a 1 underneath the 15. I see that I can cross cancel because 3 goes into 15 5 times. So 2 times 5 is 10. And then I see that I have a base of a right here and here. So I'm going to add their exponents together. 1 plus 1 is 2. Then I also have base of b. So I'm going to keep that b, add those exponents, and I get a 4. So my middle term is minus 10a squared b to the 4th power. Minus this last one, I'm going to put a 1 under the 24. Cross cancel because 3 goes into 24 8 times. 2 times 8 is 16. Keep my base of a, add the exponents. 1 plus 2 is 3. Keep my base of b, add their exponents. 2 plus 1 is 3. So my last term is minus 16a cubed b cubed. All of them have a's and b's, but they don't have the same exponents. And so this is as simplified as you can take it. So hopefully you're kind of seeing the importance of knowing those properties of exponents. All right, so next one, here we go, negative 3xy. We're going to multiply it times 2x squared y plus negative 3xy times 3xy squared minus negative 3xy times 7y squared. All right, so first term, negative 3 times 2 is negative 6. Keep the base of x, add the exponents, so we get an exponent of 3. Keep the base of y, add the exponents, so we get an exponent of 2. So the first term is negative 6x cubed y squared. Next, negative 3 times 3 is negative 9. Keep the base of x, add your exponents. Keep the base of y, add your exponents. So my middle term is negative 9x squared y cubed. Lastly, I have these two negatives. I'm going to go ahead and turn that into a plus sign right there. And 3 times 7 turns into 21. Keep the base of x. Actually, there's only one x, so that's it. It stays the same. But for the y's, keep the base, add the exponents. So I end up with a plus 21xy cubed. And this is my final answer, as none of those are like terms. All right, pretty easy so far. Let's take a look at this next one. So also, similarly, probably pretty easy. You just have a little bit of work that you have to do. You'll notice that we're going to do the distributive property twice. So we're going to distribute over here, and then we're going to distribute over here. So it's kind of like we have two separate problems, and then we'll bring them back together at the end. And I'm sorry, I keep moving, and then I hit this thing, and it shakes the table, and it shakes the camera. I apologize. Okay, here we go. So here I'm going to do 3r times 9r squared plus, and by the way, that's a typo. That plus should be like a normal plus sign. It just accidentally didn't get moved down. Plus 3r times 7r minus 3r times 12. So essentially all I've done so far is what we've done in the first 6 examples. I'm showing my work where I'm distributing the 3r. Here's what I want to show you about the second part. Because the second part, I'm not just distributing a 4, I'm distributing that as a negative 4. So let's look and see what's going to happen. I'm going to do negative 4 times 4r squared. Then I'm going to do the minus sign, still distributing a negative 4 times 3r. Then I'm going to do the plus sign, still distributing the negative 4 times 7. So you'll notice here I've distributed as a negative 4, a negative 4, a negative 4. That's going to be important. If there's a minus sign in front of the number that you need to distribute, then you've got to distribute it as a negative and not as a positive. All right, so now let's see what we've got. 3r times 9r squared is 27r cubed plus 3r times 7r is 21r squared minus 3r times 12, that's 36r. So there's the full distribution of the 3r. Now let's see what's going down with the next part. So next I have negative 4 times 4r squared. Well, that's going to give me a negative 16r squared. For the next term, I've got those two negative signs again together. That's going to turn that into a plus 12r. And then back here, I have plus negative 28, and I'm just going to write that as a minus 28. So all we've done so far is the distributive property. Here's where we get to take this problem a step further. And this is why we learned what we did yesterday, where we were learning how to add and subtract polynomials. We're just going to be combining like terms. I'm going to go ahead and keep my answer in standard form, which means descending order. So the first thing that I see is that r cubed is my highest exponent. So I'm going to keep it first. It's not going to change because there's no other like term with it. Next, I'm going to look for r squareds. I have two of them. I have 21r squared minus 16r squared, which is going to leave me with a positive 5r squared. Remember, when you're adding and subtracting, your variable doesn't change and its exponent doesn't change. The only thing that changed is the coefficient. So 21 minus 16 gave me a positive 5, and I keep the r squareds the same. Then I have negative 36r and a positive 12r. Negative 36 plus 12 is negative 24. Keep the r the same. And then lastly, we have minus 28, and there's nothing like it, so it doesn't change. My answer is in descending order, and so it's good. All right, here's where I'm going to challenge you a little bit. You may have could tell that earlier when I said, hey, when's this going to get hard? Not that it's hard. It's just going to challenge your brain a little bit. So example 8 says, find the measure of the area of the shaded region. In other words, that pink or reddish color, whatever you want to call it, I really can't tell what it is. That's the area that we want to find. So real quick, let's just talk about an easy problem real quick. Take variables out of it. Let's say that I had this picture right here, and I said that that was a 10 by 5. And then let's say that right here man, I keep killing my lid, that were a 2 by 4. And I want to know what the area is of my shaded region. Okay, well that's kind of an odd shape, right? There's not a particular shape where I have a formula for. But what I could do is the big rectangle, I could find out what its area is. Then I could find the small rectangle, this one right here. And then what can I do with that piece that I don't actually want? Subtract it. That's going to give me the area of the shaded region. So let's look at that. This is a rectangle. How do you find area of a rectangle? Easy, base times height or length times width. They mean the same thing. So for the big rectangle, that's a 10 by 5. So I would do 10 times 5, which is 50. For the small one, that's a 2 by 4. So I would do 2 times 4, which is 8. And then I would subtract the 8 away because I don't want it. I just want the shaded part, and that would leave me with 42. So that's the idea that we're going to use. The only difference is we have letters in our problem and not just numbers, but no big deal. We're going to handle that. So again, we're going to do big rectangle minus small rectangle. That's the idea behind what we're doing. So let's talk about that big rectangle. It has a 2a and then 5a squared plus 3a minus 2. So I got to multiply those together. So 2a onto 5a squared plus 3a minus 2. That's how we're going to find the area. Can y'all see that? That's how we're going to find the area of the big rectangle. All right, small rectangle. That's the white one. Let's look at its dimensions. We have an 8, and then we have a 3a squared. Oops, that's a minus sign. Minus 7a plus 1. Man, I gotta go back to 0.9 lead. This 0.7's killing me. Okay, so we're gonna take those dimensions and multiply them together. And remember we said that we're gonna do what operation in the middle? Subtraction. So now you might see why we did a problem like what we did last time where we had to learn to distribute that negative number, because that's exactly what's gonna happen in this problem. So let's start with the big rectangle. We're distributing a 2a, so I have 2a times 5a squared plus 2a times 3a minus 2a times 2. So all of that represents the big rectangle. Now I'm going to distribute not an 8, but a negative 8. Remember, there's that minus sign in front of it, so I have to distribute it as if it's a negative. So here we go. Negative 8 times 3a squared minus negative 8 times 7a plus negative 8 times 1. So again, I've shown all my work. Hint, hint, I like for you to show your work. And here we go. Let's do some math. So 2a times 5a squared is 10a cubed plus 2a times 3a is 6a squared minus 2a times 2 is 4a. There's our big rectangle. Let's take a look at the small rectangle. Negative 8 times 3a squared is negative 24a squared. Here we see those two negatives again. Remember, that's going to turn into a plus. So now I have a positive 8 times 7a, so positive 56a. And then back here, negative 8 times 1 is negative 8. So now that we have it fully multiplied, here's where we're going to use yesterday's lesson, and we're going to combine like terms. So here we go. Let's do descending order. I have a cubed, nothing like it. It's not going to change. 10a cubed is the first term. Then we have a 6a squared minus 24a squared. Remember, the a squared is not going to change, just the coefficient. 6 minus 24 is negative 18. So I have negative 18a squared. Then we have negative 4a and a positive 56a. So negative 4 plus 56 is positive 52. Keep the a. And then lastly, we have the -8. And so this right here would represent the area of the shaded region. So just keep that idea in mind that we are subtracting away the unwanted white area because we just wanted that pink or red or whatever color you view that as. That's the area that we wanted. Okay, almost done. 2 more examples. Don't worry, no more area ones, at least until you get to your homework. Example 9, here we go. So clearly we're gonna have the distributive property because I see parentheses, and it kind of looks like a whole bunch of numbers and letters, doesn't it? Don't get overwhelmed. We're just gonna go one step at a time. I'm gonna start right here with the distributive property. So let's talk about this. I'm gonna do x times x minus x times 3. Then behind it, I have plus 4x minus 3. Notice that this x doesn't get to be distributed to the 4x or to the -3 because those things are not in the parentheses. So the x is only going to get distributed to what is in the parentheses that it is touching. Over here, I've got this 8x plus 4, and then I see I've got to distribute again. And what am I distributing? I'm distributing a positive x. So plus x times 3 plus x times x. So again, just showing that work that I'm distributing. So let's do some multiplication. X times x is not 2x. It is x squared. Remember, keep the base, add the exponents. 1 plus 1 is 2. So x squared minus 3x plus 4x minus 3 equals 8x plus 4 plus 3x plus x squared. All right, let's see if we can combine like terms on either side. On the left, these two are like terms. So my x squared is not going to change. But in the middle, negative 3x plus 4x turns into a positive 1x, and then I'm going to keep the -3. On the other side, 8x and 3x, those are like terms. That's going to turn into an 11x. I still have the plus 4, and I still have the plus x squared. So we've combined like terms as far as we can go. Well, if you look at this problem, what do you notice that both sides have? Well, they both have constant. They both have an x. They both have an x squared. Let's start with that x squared. How could I move it? Easy. I'm going to subtract it from each side. And here's what I want you to notice. X squared minus x squared completely cancels. So I bring down the x minus 3. Over here, I have 11x. I have plus 4. What happens to the x squared minus x squared? You may have guessed it. It has canceled out. So we no longer have an x squared in our problem at all. And we now have a very easy problem that you knew how to do before you walked into my classroom this year, because this is now basically a pre-algebra problem. So I'm going to subtract that x on over. I get negative 3 equals 10x plus 4. Then I'm going to subtract the 4. So I have negative 7 equals 10x. And then lastly, I'm going to divide both sides by 10. I'm going to leave mine as a fraction, so I have negative 7/10 equals x. So really not too hard of a problem to do. It kind of maybe looked overwhelming at first, but once you did the distributive property and combine like terms, you have a pretty straightforward problem to do. So let's try the same method with the last example before you guys get started on some homework. Again, we're going to start with the distributive property, and it's going to happen on both sides. So I've got t times t minus t times 5 plus 2t minus 1 equals 7t plus 3 plus, here's where I'm going to be distributing on the right side, t times 8 plus t times t. Okay, so let's talk about t times t. No, it's not 2t. Remember, you keep the base the same, you add the exponents, so you get t squared minus 5t plus 2t minus 1 equals 7t plus 3 plus 8t plus t squared. I know sometimes t's can get confused with plus signs. It may help you to write a cursive T, or you could even do like what I'm doing where I try to do the little curve or hook at the bottom, whatever you want to call that. Whatever you have to do to make sure that you realize that is not a plus sign. And if you're okay with writing in print, then you keep on doing that. All right, let's check for like terms. So over here, t squared, nothing like it. But these two in the middle, I have a negative 5t and a positive 2t. Negative 5 plus 2 is negative 3, so I have negative 3t. Keep the minus 1. On the other side, 7t and an 8t adds to give me 15t. I still have plus 3, and I still have plus t squared. And guess what's on both sides? T squared. So I am going to subtract it. What's it going to do on each side? Cancel, cancel. No more t squareds. So I have negative 3t minus 1 equals 15t plus 3. All right, let's get the t's on the same side. I'm going to add 3t. So now I have negative 1 equals 18t plus 3. Now my goal is to get everything away from t, so I'm going to subtract 3 from each side. So I have negative 4 equals 18t. And last step, let's divide both sides by 18. Well, it doesn't go in there evenly, but it does reduce because both of those numbers are even, so they're divisible by 2. So I'm going to end up with a negative 2/9 equals t. And that is the final answer. So a lot of steps, but if you take your time and go through it carefully, these are very doable problems. All right, so you guys have an assignment in the book for homework. And on Friday, you'll turn that in. And there will be a link on Friday in RenWeb for a quizzes assignment. And make sure you check there as well, because I think there's something else I'm going to put up obviously before Friday comes. So make sure every day you're checking both the lesson plan area and the homework assignment area in RenWeb. Want to make sure you guys aren't turning in things late and getting points off, staying up to date. Remember, I told y'all in the last video that our goal is we're going to finish this chapter before spring break. So next Thursday, which is the last day before spring break, we are planning to have a test. So just keep that in mind and let me know if you guys are having questions, because I can set up a Zoom session. So if there's something you're struggling with, whether it's stuff from the beginning of the chapter or stuff that we're doing right now, y'all send me an email, let me know, and I can schedule something for next week or even for Friday if you need something, okay? Otherwise, have a wonderful week and weekend.